Welcome to Next in Tech, an S&P Global Market Intelligence podcast where the world of emerging tech lives. I'm your host, Eric Hanselman, Chief Analyst for Technology, Media, and Telecom at S&P Global Market Intelligence. And today, as the seasons are starting to change, we're going to be discussing migrations, the great data migration. And joining me is Research Director for Storage, Henry Baltazar. Henry, welcome to the podcast.
Thanks, Eric. Happy to join and looking forward to a lively discussion.
Well, thanks for being on. There's research that came out recently that shepherded about trends in migration. And I think it's one of the things that the team really talks about a lot in terms of where data is, where it needs to be. It's migration to cloud has been such a big theme for so long that I think in a lot of cases, the workload part of migration to cloud has really overshadowed the conversations about what's really the much more critical part, which is the data side. And that's something that we've been tracking, and recent studies actually got some interesting insights on.
Yeah, I definitely agree. And I think the main point I'm thinking about when I look at this market and what's been changing is just the importance of data migration and why we need to think about it more. Because at the end of the day, everybody's talking about we want to be hybrid multi-cloud, we want to be able to leverage multiple execution venues, blah, blah, blah. In the old days, when you thought about data migration, you thought of it as more of an episodic thing, like the terrible use case of moving your house. Hopefully you're not doing that all the time. So most people were used to thinking about migration like, okay, we'll move a bunch of data every couple of years or whatever and retire hardware or retire data centers, blah, blah, blah. But as we start getting to trying to exploit the value of hybrid multi-cloud, we're moving this from being something where we're only doing it a couple of years or big changes to the infrastructure or IT organization to potentially, in some cases, a lot of our customers, a lot of the respondents in the surveys are actually moving data on a daily basis or quite often.
Well, that's an interesting point because there really was that idea of back in the day, if we can talk about back in the day when we're talking about cloud, there was this idea about, we're going to move to the cloud and it's a one and done thing. We're just going to move everything over and then bonk, we're set. That's the end of it. But realistically, we're now to a point at which we've got critical production workloads running in various places. We've got an application ecosystem that is a lot more complicated and distributed than it used to be. We've now actually got to ensure that data is wherever it needs to be for performant access. And at the same time, this data that also has a lot of temporal specificity. It's real time or near real time. It is timely updates that have to be happening. That means we're now really treating this whole process a whole lot differently.
Yeah, absolutely. I mean, I don't think anybody wants to think about moving their house as a process they want to do over and over again and repeatable, but that's kind of the world we're living in now. If we want to take advantage of multiple execution venues, multiple technology suppliers, multiple localities, or whatever we need to do, that all involves moving data. So we can't afford to think about it as, okay, I'm just going to hire somebody to move that today. Because it's a problem you might have every day or something you need to be able to have competency in doing every day. Because your stakeholders need to be able to react. There's an emergency job and they need to be able to do it in so-and-so cloud or so-and-so venue. Guess what? You can't do any of that. I don't care how many GPUs or whatever you have on that other site. You can't do any of that until you have the data there. And I think that's the fundamental thing we have to think about. How do we make sure the data is in the right place or can get to the right place by the time we need to use that execution venue?
All right, well, then we've got to come up with a better analogy than moving our house. So stumped as to what that could potentially be. I guess maybe is that something where the electricity analogy, we got to make sure that power lines are getting to all the places we need power to be, something like that. Hey, we've talked about data being the new oil. How about data being the new electron? Maybe that's a bit of a stretch. But to your point, it's something where this is something that we've got to work at establishing data pathways. And we also talk about data fabrics and getting to a point of thinking about the means to distribute data and not think about data as being sitting in static repositories and being in that one place. And that is the repository for the data. It's that data, in fact, is more fluid. It is a capability that has to be moved places in order to be useful.
Yeah, I 100% think that. But I think another thing, if we take a step back and look at people and their data, the companies and their data under management, when we look at the surveys, most of the respondents have multiple copies of data. Yeah, they'll have 4 or 5 different copies of data. The thing is, as we start looking at all these different issues, ransomware, all these other things, global distribution of data, if you want to be able to make workloads or data accessible to multiple geos, you're going to have having multiple copies of data is price of doing business. I think what we need to do is figure out, okay, if we're going to have multiple copies of data, where should those copies reside? And let's take advantage of low cost archive storage if you can do it in the cloud or some other areas like that. So you can have another copy, a low cost copy of that, which could be activated or synchronized quickly so that your production data versus that offsite copy, hopefully you could just send the deltas over to make that secondary copy or archive copy up to standard with the production, and then you can launch the workload there. I think those are the types of things we need to start thinking about in terms of where should data be, where should these copies of data be, and how do we make sure we can have it so we can activate these things. Let's say there's a great workload. We've been running this in North America. We need to do that in Europe now. Well, it'd be a lot easier if you had
The data was there.
yep, if it was there and you could sync it up quickly instead of saying, oh, I wish I had that petabyte of data over there on the other side. Yeah, that's where we have to start making better decisions about, okay, copies of data are price of doing business. Let's be smarter about where we put those copies of data to make sure we put them in different areas for geographical availability or for mutability and protection for ransomware, break in case of emergency copy. Or, maybe you're trying something out in another cloud. You're going to want to have some of that data there as well. Maybe try out a new AI algorithm or whatever new thing comes out from a cloud provider. So there's a lot of reasons, and I think that's what goes into it. I think a lot of people think data migration and things like that's kind of a boring blah, blah, blah sector. It's a chore. But going forward, we need to integrate that into processes because if we don't do that right, you can't really extract the value of the multi-cloud resources.
Well, I think the difficulty also is that we haven't gotten particularly good at figuring out what the data is we have, what we need, and where it needs to go. It's the age-old problem of data classification. If we had some idea that, this is a customer database, it doesn't change instantaneously, but there needs to be enough synchronization in it that this application that registers new customers needs to be able to get access to the current ones so that it can figure out whether or not this is somebody who's already a customer or not. Those kinds of things about the data that then is up to the minute statistics about, hey, the shopping transaction that I need to make sure that this is a reasonably atomic thing because I'm going to pull one out of inventory and make sure that I can sell it, but also don't want to sell one that I don't have. Those sorts of things. Now life gets a lot more complicated in terms of figuring all this stuff out in ways that we haven't typically dealt with in the way in which, at least from the IT perspective, we understand the data. Maybe the application owners know that, but there hasn't been that coordination in terms of ensuring that the infrastructure is meeting the needs of the applications for the data that we have and what's available.
Yeah, I agree with you. I think that's kind of the strange thing about this market. It's not really just technology problems. A lot of it is really cultural and information sharing problems. I mean, one of the top things I see that break and totally break a hybrid cloud deployment is when the infrastructure people or even the cloud people just don't fundamentally understand the workload itself and don't really understand what type of customer experience needs to happen. In a lot of cases, we've seen some organizations, especially organizations that are doing a lot of digital image archiving and whatnot. Typical story is the poor storage administrator sitting there and CIO walks into his office and says, hey, we're moving to cloud. So you're not buying any more of the scale out NAS you've been buying for years. Have fun with that. And the poor storage admin's got to go walking around with his tin cup or her tin cup and saying, please tell me which data is not as important or infrequently accessed, and I'll move that to the cloud because we need to free up because we're not buying any more capacity. And of course, they go to the business stakeholders, and of course, the business stakeholders say, all my data is important. You can't move any of it. And eventually, push comes to shove, the deadline comes up, and I've seen this a number of times already. The poor storage administrator has no choice, but okay, what do they have? Okay, well, you're not going to tell me about the workload. I'm going to go to NFS or our file shares and look at the metadata there and says, okay, these are all the files that haven't been touched in 7 years. That's going to go first. And sometimes that works, but in a lot of cases, it goes horribly wrong because
That moment of, so like, wait a minute, what happened to? Yeah.
exactly, because we see a lot of these cases happen where, okay, let's move. You haven't touched it in 7 years. Pretty good chance you're not going to need it until an audit comes or a new research product comes or a new blah, blah, blah comes. And then you drag it back. And that comes into the other part, which we're probably going to be talking a lot, is the impact of cloud egress charges and having to pay for those egress charges to get access to your own data or retrieve your own data from a public cloud and bringing that back off the cloud.
This is just the latest stage of the, oh, rats, this stuff costs money to run sort of thing. And a lot of these realizations from the capital expense, we buy infrastructure and then we own it. We don't worry about what it costs us to actually use it, to now the operating expense conversation, which is, oh yeah, it actually costs to use it and costs you to do all the things with it. So we figured that out with workloads. Like, hey, if you don't turn that workload off, it's going to continue costing you money for a while. So, hey, the thing we keep talking about for cloud, you got to figure out how to turn things off. And now data. I mean, who knew it costs money to move bits back and forth? It's the latest sticker shock in that next generation of digitization. And you've got a lot of data in terms of the extent to which that's becoming a much larger consideration.
Yeah, especially as we start thinking about data-centric applications and really, really large data sets moving around. And we need to get smarter about making sure if I'm putting it in the cloud, in an archive tier, it's really there to be archived. Like there's very little chance that I'll need it back. Or if I need it back, it'll be a small subset of that because, yeah, you could spend more on egress charges than what you're spending for a year keeping it in an archive layer. So if that's the case, then why'd you even do that? You probably shouldn't have moved it there in the first place. So those are the type of things we need to get smarter about. If we're going to put it there, make sure it's not coming back or make sure it's reasonable in terms of what we'll spend in those networking costs and expenses to bring it back here, not back on premises or wherever else.
Yeah, I mean, it gets back to your earlier point, which is that we've actually got to have an understanding about what that data is and how it's being used. And we've got to bridge those barriers that often exist between those who are actually implementing the storage capabilities and the applications that are leveraging it. Because, hey, it looks really attractive. That long-term cold storage option from my cloud provider is really cheap. This is great. Until you have to suck a whole bunch of data back out of it because, hey, it's not really what it's built for.
Yeah, let's be real about it. I mean, the cloud people want their data in their cloud, right? Because at the end of the day, they may have a million different services, but a lot of those services they can't really sell to you until you have your data. So there's incentive for them to grab as much of your data as possible in the cloud so they can sell AI services or whatever services they have, compliance services, transcoding services, whatever else they can make money on. They need your data. And likewise, they don't necessarily want your data to leave either, which is why we have the egress charges, though they'll frame it as, well, networking's not free, so that's why we have egress charges. But that's not all of it.
Yeah, pick your analogy. Hotel California, Roach Motel. Yeah,
the data checks in. I was trying not to go that route, but yes, indeed.
Oh, come on. You could count on me to go there. But that's the challenge. And again, you mentioned some of the most data hungry environments that are out there. That's all the big level analytics, AI use cases. Guess what? You've got to be able to go haul all that data into an environment where you can leverage the analytics. And cloud is a great place to get relatively low cost analytics for large volumes of data. The question, though, is that can you do that in a way in which you hang on to the data you've got? You get a working copy that exists in the cloud that you can then just simply discard and not have to worry about getting back out, dealing with the egress charges that it takes to move all that data back out.
Yeah, and I think that's where you can get smart about it. And I think that's where the optimization play comes into effect. Because as we were talking about, there are a lot of egress charges if you want to drag data back. There are no ingress charges, so I can move as much data as possible into wherever I want to put it and just pay for the data as it is. So maybe one of the workarounds could potentially be, fine, there's no ingress charges. I'll throw a bunch of data up there for a week and pound away on it. And hopefully the egress charges are small because I only want the result back after we're done using all the GPUs, virtual servers, or microservices that we're consuming in the cloud. After we've gotten to the right outcome, hopefully that byproduct is much smaller than the data set we may have thrown up there. And then we can get smart about, I think the one magic superpower of cloud we never talk about, we always talk about elasticity and geographic reach, blah, blah, blah. To me, the superpower of cloud storage is making it disappear because that's something you can't do with on-premises, right? I mean, if I bought many, many, many petabytes of storage, that's sitting in my data center. I paid for that. Sure, there's more elastic models in place now that are coming into play. But one of the things that you like about cloud storage is I moved the data up there. We ran that workload for a couple weeks, killed it. Now we pay a prorated amount, dollar per gigabyte per month, whatever, and only pay for that and not pay the egress charge to drag the whole thing back.
And well, it seems like it gets into the whole question of, much like workloads, you have to remember to turn them off. And for efficient data management, you have to remember to delete it.
Yeah, I've had those conversations with the big hyperscalers. I mean, a lot of them will say, oh, we've done all we can to help customers and we've had tiering and blah, blah, blah. And sometimes they go through their presentation. It's like, okay, you just discussed a bunch of different features and functionality. I'm getting dizzy just from this 1 hour conversation of talking all these different versions. I'm hoping the hyperscalers and service providers and whatnot start working towards making it easy. So I don't have to memorize all the different categories and all the different tiering type capabilities that are already there. Yeah, so we can do a better job of automation, do a better job, and make sure we're extracting the maximum amount of value out of the money we spend out of our storage and infrastructure investments.
Well, now you mentioned tiering. And this seems to me to be one of those everything old is new again, because tiering back when storage was really expensive and we had more limited options and options more than anything else that actually had really significant performance differences when we had large arrays and things and tape and all the rest. And tiering was something that was a critical part of ensuring that we operated efficiently. When storage got cheaper and we got much larger integrated arrays, the importance of tiering tended to shift, at least from my perspective, it tended to really sort of fade a bit. But now that, again, we're in these environments where if we've got something that's on-premise, cloud, it's in this different way, it's in colo, whatever. Now there are these big differences in access performance. We're right back into the importance of tiering again.
There still are, and the access performance, there's a price to pay to there, right? I mean, some cases, if you really need an emergency, you could pay fees to accelerate the retrieval. A lot of the service providers have that. So that's one break in case of emergency thing if I need to grab it from the archive and get access to it right away. But I think one of the interesting points you made is you were talking about as if it's a past world, but it's still very much real world. Though, I mean, if you looked at the storage market, you'd think, oh, disk and tape are dead. It's all flash, blah, blah, blah. And that's what you'll hear from a lot of the main on-premises vendors. Guess what? There's still a lot of disk being sold. There's still a lot of tape being sold. And a lot of that is still being sold to hyperscalers. You're just not seeing a tape library. You're just seeing it as an archive service.
And there's something behind it, but yeah.
Yeah, because there's no secret there. If you look at the earnings of some of the big tape providers that are left, a lot of their sales are going to hyperscalers. So even though the hyperscalers may not be going out saying, hey, we're using a bunch of tape, there's probably a bunch of tape out there. So, but again, the key thing I think is missing in the equation is I think a lot of organizations just don't have the right level of data intelligence in terms of what exactly is the data we have and how do we make sure we're managing it the right way and how do we make sure we're automating it, because the problem is data value is constantly changing. Something that's really important right now might not be important 6 months from now. Why is it sitting on all flash storage or something ridiculously expensive? We should be freeing that up for other things. And a lot of times people are worried about the thrashing, they're worried about latency, they're worried about these things, and they just sit there and, as you were saying, leave the water running, which becomes a gigantic resource consumption sink. So we need to get better about understanding how these things are changing real time and use those things to be able to do the automation. I think what from the cloud provider side, hyperscalers are saying, well, we're providing automated tiering capabilities, so we're going to be the ones that watch and monitor and make sure, hey, that workload's a little slow, hasn't been used in a while. We'll drop that down to our archive tier so you don't have to worry about it. But Again, I think it's a work in progress. I think hopefully these models get easier and easier because operational costs continues to be one of the big challenges on the storage side.
Well, and simply moving that much information around. And you mentioned that, hey, tape really still is a thing. The thing that I was fascinated by in the study data is that the physical movement of data for migration is still such a big component. We all think about, hey, I'm a networking guy. We've got all these now amazingly super fast pipes to go everywhere, and we're just going to transfer all of our data, via whatever massive, 100 gig, 800 gig connection we've got. That's not the only thing that's happening. And a big piece of this is actually physically shipping media around.
Yeah, of course. I mean, that's one of those interesting things about the recent changes over the last couple of years. Just a few years ago, when we looked at survey data, the majority of the respondents we talked to in terms of moving data to cloud, they basically did that over the network and that was fine. I think what's changed is as the organizations start accelerating their cloud migration and accelerating their use of public cloud resources, the data sets have gotten bigger. And when that starts happening, then it becomes a physics problem. Then it becomes okay, that was great for a couple terabytes here and there, a couple terabytes a week, or blah, blah, blah. We can handle that, or we can wait that out for that data to move. Well, what happens when it's petabytes or exabytes moving? And you could talk about months and months and months of time to get that moving. Business stakeholders are not happy about, oh, your data set will be available in a couple months. No, that's not going to happen. So that's why, in order for them to do that, they're looking at doing physical transports. We've definitely seen greater popularity for provider-enabled physical transports. Products like AWS's Snowball, for example. A lot of organizations are starting to use that to do like a local copy, and then they ship that to AWS to move that data. But we also still see people physically shipping arrays to their cloud provider. We do see them shipping tapes. We see them shipping data and other physical means to be able to move that data, especially if they can't wait for that data to trickle over the network to get to the cloud.
Well, it gets back to the old adage, your fastest network connection may be a Federal Express label. So
Yeah, SneakerNet is still here.
if you mentioned Snowball, which for those of our listeners who don't know it, I mean, it's a big disk array that basically is in its mid-size, that actually there are versions of the whole system that you can actually get a container-sized set of storage if you really want to go there. But the whole idea is you basically sit it in your network and then physically ship it back to your cloud provider and off it goes.
Yeah, in some cases, that probably makes the most sense, especially if you want to move that data and be able to use it in a timely fashion. That might make sense for some organizations, or it could make sense for, we don't even talk about edge. I mean, what happens if you're in an edge environment where you're probably not going to get the best bandwidth back? If that's the case and you have valuable data that you maybe want to do crunching of that in the cloud or on premises even, you're probably thinking about potentially using a physical device or physical shuttle devices to move that data instead of trying to move it over a network link that wasn't designed to move petabytes of data.
Yeah, I've seen use cases, in fact, where there's satellite data, basically very large volumes of imaging data that hit a ground station that is located far from high capacity networks. And simplest thing for them is to just have a constant rotation of physical systems that they're shipping back and forth.
Yes, I think that's going to be the case for a lot of these things. I mean, even like some of the data that's on ships and whatnot for the oil exploration or whatever. A lot of cases there, if they don't have the bandwidth, then physical shipping might be the best option for moving some of that data.
Well, we talk about the connectivity of satellite networks, and now with the advent of low Earth orbit, there's more and more capacity that's there, and maybe there's competition in low Earth orbit sometime soon. But still, we're not talking about the kind of connectivity that is going to let you move petabytes of data quickly.
Yeah, I've got enough to handle on the storage side. That's your area. I hate networking.
All right, well,
Sorry,
I'll take that on. Well, so what should organizations be thinking about as they start wrestling with this? I think the interesting thing about the study, as you're pointing out, is that people are moving production applications with production-sized data sets into cloud. How are ways to think about this that help them actually along this journey as they move forward?
In my opinion, I think it starts at the top. I mean, it starts with the data intelligence. Let's really understand what the data is, what the workload is. If you can't get through it culturally, unfortunately, the next stage is, okay, let's try to bring in some tools that can analyze the data for us, tools that can analyze what types of data or who the users are of the data, to give us a better idea so you can have a more focused conversation about, hey, this is what you're consuming, this is how you're using it. A lot of this data is not being used, potentially save. Maybe they can make it more incentive based in terms of, hey, if we do this and move to so and so lower cost archive tier, we could free up this kind of money. Maybe that helps you with your budgets. Maybe you can try to create more incentive type areas to make it not just a chore for the business stakeholders and the application stakeholders to work with the infrastructure teams to make a better decision about where that data could be or should be. Likewise, in regards to that data intelligence, we didn't talk about it too much, but there's also the fear of compliance too, right? Compliance and security are going to have a role in this as well, in terms of where data is and how it's protected and whatnot. And those are also considerations we have to think about too in terms of moving it, because you don't want to move data to an area if your organization has global data sovereignty restrictions. You don't want to move it to an area you shouldn't be in and not only break your own regulations, but, oh, by the way, it's going to cost money to bring that back too. So again, I think it starts at the top. I think one of the things to work on is how do we get that insight into our workloads, into our data so we can make the right decisions? Because the best way to see it is the best move is the move you shouldn't have made or you avoided making. The best move is avoiding a bad move is actually the best move sometimes.
Well, and this is the issue that you brought up, the security, privacy, and regulatory pieces. All of these things, if you actually get better understanding of your data, all of these areas benefit. And we've talked with Paige Bartley about all the privacy and regulatory pieces, and security team about the challenges of not knowing how well to protect or in what ways to protect data. And it all gets back to the same point that you made.
Yeah.
Clearly work to be done on that front.
Absolutely. And just one last point, one last area, especially because this is one of the things that, to me, break hybrid cloud deployments, is not understanding things from a latency and performance perspective. In some cases, we talked to, it was a medical research and hospital type of company. They moved some of their digital imaging to a co-location site. They didn't realize what was going to happen to the customer experience in terms of latency. And it took all of 2 days for the doctors to say, get this out of my hospital. So we need to understand and make sure, I think organizations need to also, after they make those decisions on, oh, this is the data, this is what it should be, they should also spend that time to do the testing to make sure, is it actually really going to work there with a smaller abbreviated data set, to make sure and validate that works. Likewise, we don't really talk about it as a workload migration thing, but disaster recovery as a service is, at the end of the day, it's basically data migration break in case of emergency or workload migration break in case of emergency. So we need to start thinking about these things in terms of how do we do the testing and make sure, if we are making these moves, are we sure that when we have to flip the switch and turn on that next execution venue, that it's actually going to work? Because again, if it doesn't, then why did we move there? Why did we move the data there in the first place?
Yeah. And again, it gets right back up to the question you made, or the point you made at the outset, which is we've got to get much better at understanding what that data is and how we need to deal with it. The laws of physics still apply. If you put things far away from you topologically, it's going to take longer to get there. All those good things. Oy. A lot of things to talk about. Well, thank you, Henry. This has been great.
Thanks for having me, Eric.
And I think maybe a follow-on with more discussion around these additional implications. We can actually dig into some of the specifics about it. So until next time. But for now, that is it for this episode of Next in Tech. Thanks to our audience for staying with us. And thanks to our production team, including Carolyn Wright, Caitlin Buckley on the marketing and events teams, and our agency partner, the 199. I hope you'll join us for our next episode, where we're going to be talking about digital finance. A lot of things that are taking place in that, and the Money 2020 conference that's coming up. I hope you'll join us then, because there is always something next in tech.